Hello everybody, in this video we're going to be discussing when you should solve an F2L case rotationless. For example, we have this F2L case here, and what a lot of you would do is this. Okay? But if you get it from this angle, you could also do it like this. So which way is faster? So we need to figure out when it's best to do a rotation and when you should just forget about that. To find whether a rotation is faster, we first need to look at how long it takes you to do each alg, okay? So you want to time yourself on each alg and get a rough approximation of how long on average it would take you to do the alg. And then you want to figure out how long it takes for you to do a cube rotation, okay? Now this might be a little bit difficult to do, so what I recommend doing is recording a solve and have a timer in the background showing your current time. And you can either use that or use an editing software to figure out about how long it took you to do a cube rotation and all that other stuff. That will give you a rough approximation of how long it takes for you to do that. So we have the three variables, and now I'm going to show you how you can plug them in to determine when to do a rotation and not to do one. This equation here shows you how to plug in the variables that you found. And if this equation works, that means it is worth it to do a cube rotation, okay? So the first algorithm would be for instance, your algorithm that's 2gen, or the second one would be the algorithm that you use at a different angle. And then rotation is how long it takes you to do rotation. And all this is in time, okay? So you want to find the absolute value of the difference between the times. So basically that means what the difference between the two times is. Because if you flip-flop those, the greater one might be the one that's being subtracted, and then you get a negative number. So that's why we need an absolute value there. And then all that needs to be more than the amount of time it takes to do a cube rotation. The reason it's bigger is because if the algorithm that you do has a ridiculous amount of moves just to save you from a cube rotation, then it's clear it's not worth it to do it. So this will show you the way to determine that. Now that you know how to calculate when to do a cube rotation and when not to, now we're going to look at some examples of when, disregarding that, it actually does make sense to do a cube rotation even if the equation does not work. Here's an example here. So we have this pair here, and this pair back here is already solved, okay? So if we solve it normally, we get this. So we get one pair in the back, which isn't too bad, but if we rotate like this and solve it like this, now both of our solve slots are in the back, and then that will maximize our look ahead. A similar example is if it will end up putting both your solve slots in the front, then it'll be very hard to see the back, and you should rotate to get at least one of those towards the back. Taking this a step further, we can also use this to simplify our next step. For example, this case here. So we have this once again, and if we solve it normally, we get an OLL like this, okay? So the OLL wasn't too bad, but if we rotate, we do this, and we get a PLL skip, or sorry, an OLL skip, okay? So as you can see there, rotating gave us an OLL skip and simplified our next step. This can also be used in multi-slide to simplify your next F2L case. This would mean you see your next F2L case and you determine which solution would give you the best case. But the problem that arises with this is, doing a cube rotation might simplify a case just slightly, but it might not do it to the point where it actually sets it up for you, and it's better to just forget about rotating. So basically what you're trying to find is you want to figure out which solution will take the least amount of time to solve your case and then your next step, and whichever one takes the least amount of time is the route you should take. So I just mentioned how you can use a cube rotation to your advantage regardless if the solution is a little bit longer, okay? But the cases where it does matter to figure out the solution that's the quickest for rotating is when cube rotating would have the exact same effect as if you didn't. For instance, we have this case right here where we would solve it normally and we'd have one slot solved in the front and one in the back. However, if we rotated, we would have the exact same result. This is a case where it is very critical to determine whether your solution rotating or not rotating would be quicker, okay? So that's what you really got to use this for, okay? So these are the kind of cases that this is very helpful for. So in this case here, I would probably just solve it like this. And I see we have this, and we can insert like this. So that's another thing that you can also use, is whichever case will set up your next pair would also be helpful. But if you're not worrying about your next pair or you're on your last F2L case, that's where it does make a difference. So you can't figure out the shortest solution while trying to simplify your next pair. So it really comes down to which one you'd rather do and which one you feel is more efficient for you. So if your look ahead is not that great, then it would be better if you just do the algorithm that is the most efficient. But if you're going to do a rotationless, at least know how to avoid bad cases. For instance, we have this case, okay? And if we do it the normal way like this, we'll get a pretty decent OLL, and we could actually do EO right here. And in this particular case, down to the corners, we can actually skip OLL, okay? However, if we do it like this, we get a dot OLL, which is we all know is really bad, and you should at least know how to avoid these cases and at least memorize the solutions for those. So that way you just rotate and get rid of this, because it's better to rotate than to do this. So I hope this video was helpful for you guys. Let me know what you guys think about this, and I'll make more of these. So thank you guys for watching, and I'll see you guys on my next video.